Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to my YouTube channel. How are you today? Okay, I hope all of us is very well and happy every day. Okay, so in this video, I'm going to explain about geometric and spatial sequence. This video to fulfill my assignment in subject English for teaching mathematics. Okay, now let me introduce myself. My name is Shinta Armeynda. You can call me Shinta. I'm from Martapura City, South Borneo. My major is Mathematics Education and my class B 2018. And now I'm studying at UIN Antasari Banjarmasin. My lecturer is Mr. Ahmad Wafanizami, MPD. Okay, that's all. Let's get started and hope you enjoy this learning video. Geometric sequence and series. Learning objectives. First, identify the common ratio of a geometric sequence. Second, find a formula for the general term of a geometric sequence. Third, calculate the nth partial sum of a geometric sequence. A geometric sequence is a sequence of numbers where each successive number is the product of the previous numbers and some constant r.
A sub n is r times a sub n minus 1. And because a sub n divided by a sub n minus 1 is r, the constant factor r is called the common ratio. For example, the following is a geometric sequence 9, 27, 81, 243, 729. Here, first term is 9 and the ratio between any two successive terms is 3. We can construct
the general term a sub n is 3 times a sub n minus 1, where first term is 9, second term is 3 times first term is 3 times 9 is 27. Third time is 3 times second term is 3 times 27 is 81. Fourth term is 3 times third term is 3 times 81 is 243. Fifth term is 3 times fourth term is 3 times 243 is 729.
In general, given the first term and the common ratio of a geometric sequence, we can write the following. Second term is r times first term, third term is r times second term is r times first term times r is first term times r squared. Fourth term is r times third term is r times first term times r squared is first term times r cubed. Fifth term is r times third term is r times first term times r cubed is first term times r to the power of 4. From this we see that any geometric sequence can be written in terms of its first element, its common ratio, and the index as follows. A sub n is first term times r to the power of n minus 1. In fact, any general term that is exponential in n is a geometric sequence. Example geometric sequence. First, find an equation for the general term of the given geometric sequence and use it to calculate its 10th term is 3, 6, 12, 24, 48. So the solution: begin by finding the common ratio. R is 6 divided by 3 is 2. Note that the ratio between any two successive terms is 2. The sequence is indeed a geometric progression where first term is 9 and R is 2. A7 is first term times R to the power of n minus 1 is 3 times 2 to the power of n minus 1. Therefore, we can write the general terms a sub n is 3 times 2 to the power of n minus 1. And the 10th term can be calculated as follows. 10th term is 3 times 2 to the power of 10 minus 1 is 3 times 2 power 9 is 1536. So the answer a sub n is 3 times 2 to the power of n minus 1. 10 terms is 1536. Geometric series.
A geometric series is the sum of the terms of a geometric sequence.
For example, the sum of the first 5 terms of the geometric sequence defined by a sub n is 3 to the power of n plus 1 follows. S sub 5 is sigma and equal 1 to 5. 3 to the power of n plus 1 is 3 to the power of 1 plus 1 plus 3 to the power of 2 plus 1 plus 3 to the power of 3 plus 1 plus 3 to the power of 4 plus 1 plus 3 to the power of 5 plus 1 is 3 squared plus 3 cubed plus 3 to the power of 4 plus 3 to the power of 5 plus 3 to the power of 6 is 9 plus 27 plus 81 plus 243 plus 729 is 1089. Adding 5 positive integers is manageable. However, the task of adding a large number of terms is not. Therefore, we next develop a formula that can be used to calculate the sum of the first n terms of any geometric sequence. In general, S sub n is first term plus first term times r plus first term times r squared plus first term time r to the power of n minus 1. Multiplying both sides by r, we can write r times s sub n is first term times r plus first term times r squared plus first term times r cubed plus blah 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 plus first term times r to the power of n. Subtracting these two equations, we then obtain s sub n minus r times s sub n is a sub 1 minus a sub 1 times r to the power of n. S sub n times 1 minus r in bracket is a sub 1 times 1 minus r to the power of n in bracket. Assuming r not equal to 1, dividing both sides by 1 minus r leads us to the formula for the nth partial sum of a geometric sequence. S sub n is a sub 1 times 1 minus r to the power of n all over 1 minus r. R not equal to 1. In other words, the n partial sum of any geometric sequence can be calculated using the first term and the common ratio. For example, to calculate the sum of the first 15 terms of the geometric sequence defined by a sub n is 3 to the power of n minus 1. Use the formula with a sub 1 is 9 and the common ratio is 3. A sub 15 is a sub 1 times 1 minus r to the power of 15 in bracket all over 1 minus r is 9 times 1 minus 3 to the power of 15 in bracket all over 1 minus 3 is 9 minus 14,348,906 in bracket all over 2 minus 2 is 64,570,077. Okay, now we discuss example geometric series. For the question is, find the sum of the first 10 terms of the given sequence 4, minus 8, 16, minus 32, 64, and blah blah blah. The solution determine whether or not there is a common ratio between the given terms. R is minus 8 divided by 4 is minus 2. Note that the ratio between any two successive terms is minus 2. Hence, the given sequence is a geometric sequence. Use R is minus 2. And the fact that first term is 4 to calculate the sum of the first 10 terms. A sub n is a sub 1 times 1 minus r to the power of n in bracket all over 1 minus r. S sub 10 is 4 times open square bracket 1 minus 2 to the power of 10 the square bracket all over 1 minus in 2 is 4 times 1 minus 1024 all over 1 plus 2 is 4 times minus 1023 all over 3 is minus 1364. So the answer for S sub 10 is minus 1364. Okay friends, now we will discuss about spatial sequence. There are some spatial sequence that you should be able to recognize. The most important of these are the first is square numbers, second is cube numbers, and third is triangular numbers, and fourth is Fibonacci sequence. So, square numbers like 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, and etc. The nth term is n squared. They are the squares of whole numbers. 0 is 0 times 0, 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, etc. Now, let's look up the picture. Second is cube numbers. cube numbers like 1, 8, 27, 64, 125, 216, 343, 512, 729, blah blah blah, and the nth term is n cubed. They are the cubes of the counting numbers. They start at 1. 1 is 1 times 1 times 1. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. 64 is 4 times 4 times 4, and etc. And then look at this picture. 1 is the first cube number because 1 times 1 times 1 is 1. And the shape like this. And then 8 is the second cube number because 2 times 2 times 2 is 8. And the shape like this. 27 is the third cube number because 3 times 3 times 3 is 27. And the shape like this. Then 64 is the fourth cube number because 4 times 4 times 4 is 64. And the shape like this. Okay? Understand? Third, triangular numbers. Triangular numbers like 1, 3, 6, 10, 15, 21, 28, 36, 45, and etc. These numbers can be represented as a triangle of dots. The term-to-term rule for the triangle numbers is to add one more each time. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, etc. Then you can see a pattern like this picture and like this. Fourth, Fibonacci numbers. Fibonacci numbers like 1, 1, 2, 3, 5, 8, 13, 21, 34. The Fibonacci sequence is found by adding the two numbers before it together. The 2 is found by adding the two numbers before it. 1 plus 1 is 2. The 21 is found by adding the two numbers before it. 8 plus 13 is 21. The next number in the sequence above would be 55. That is 21 plus 34. So, look, this is the Fibonacci number pattern.
Okay, that's all from me. Hopefully it's useful. Sorry if there is a shortage. And thank you. Wassalamualaikum warahmatullahi wabarakatuh. See you guys.